Hey math kids, today we're going to talk about Pearson's product moment correlation coefficient. Now, most of the time we just call that the correlation coefficient. I don't know anyone that refers to it by its full name all the time. And to be honest, I don't even remember the full name. I just happen to be reading it right in front of me. Okay, so we're just going to refer to it as the correlation coefficient, which often I'll just call R. Okay. Now, in your book, you can look at the actual formula for this. We have some summation symbols. We have each value individually minus the average of those x values. And then we look at the same thing with y values. Then we divide all of that, square root that, sum the square of that difference. All right, so this is a big formula. Now, and this is equal to R. We're not going to do this by hand though, so don't worry. Just understanding what it is the most important thing. Okay, so there's a table in your book on page 456 that tells you that R is equal to 1 is a perfect. So that means it's fully linear. Okay. Same thing, R negative 1 is also perfect, but this is just going to have a negative slope. This is going to have a positive slope. Now, something that's like, the contrast to that is if we have 0.5 or lower, we're going to say very weak. And this one would be, okay. And then there's different levels. I'm going to let you look at the thing in your book, though. But we have very strong, strong, moderate, weak, very weak. And it's just a different scale. So what this tells us is it tells us how linear our data is. So if we get a 1 or a negative 1, it's perfectly linear. If we get like a 0.25, it's not very linear. Okay. So I'm going to just go through a couple examples. So the Department of Road Safety wants to know if there is any association between average speed in the metropolitan area and the age of drivers. They commission a device to be fitted into the cars of drivers of different ages, and the results are shown in the scatter diagram. Now, if you just look at the diagram, it's, once again, you're going to have to look. This is example 1 on page 456, but it definitely does not have a strong linear correlation. It, barely even looks like it has a correlation. So it kind of looks like this. All right. That's not a perfect drawing, but right here is 20. Right here is 90, 32 to 40. Okay, so this is kilometers per hour, and this is age. Okay, so there doesn't appear to really be a correlation between age and how fast you drive. Okay. So it says the results are shown in the scatter diagram. The R value is, they give us the R value, which is 0.027, which is very low, because if we round that, that's 0.03. And anything below 0.5 is pretty bad. So we're going to say that this is very weak at best. Okay. So very weak, but it is positive. And we can see there is a little bit of a positive line going through that. It is going up a little bit, but it is very, very weak. Okay. All right. So that's just kind of visually looking at that and determining that. Now the next one that we're going to look at, which is also the last one, we're given a table that looks like this. So A, B, C, D, E. And these are different chemicals that they're trying out on a lawn to see which one helps it grow the best. And this is the quantity that they're adding. This is measured in grams. This is sample. And then number of surviving beetles. Oh, sorry, I misread it. So yeah, this is controlling a beetle infestation in a plant. Okay, and then this is number of beetles. And so that's going to be 11, 6, 4, 6, 3. Okay. Now, what we're going to do is we're going to do a linear regression. And I'm going to pull out my calculator. So first what we need to do, we need to enter this into a list. And I'm not used to doing this on this calculator, so I can't find it off the top of my head. Okay, here it is. Second. Nope. So we just go to stats, actually. Go to edit. And we enter in, so I'm going to enter in this column. So 2, enter, 5, 6, 3, 9. Go to list 2, enter the other data, 11, 6, 4, 6, 3, and we just quit. And now we want to do a linear regression. So I went to second list, and now I'm going to go to calc. All right, and I want to go to linear regression. And then I do x comma y. So it was list 1 comma list 2. I'm going to go second, list 1, comma, second, list 2. Hit that. Okay, that gives me the equation of the line. I did forget one thing. So we want to go to catalog, and we want to go to diagnostics on. So I'm going to hit D to jump down to that. And we want to turn diagnostics on. Now, my calculator resets every time I go into it, so I have to do this every time I turn on my calculator. But if you have an actual handheld calculator, you only have to turn it on once, and then it's on forever. And so now I just need to run that again. I just need to go, I just need to say stat, go to calc, run the linear regression, do L1 minus, or L1 comma L2. And now it gives me the R value. So my R value is 0.859 if I round to 3 significant figures. Is that 859? I already forgot what I said. Let me just double check that. 0.859, yes. Okay, so that's my R value. And if we go to the table, we see on the positive side that 0.859 falls into this range. And they label that as moderate positive correlation. Okay? And so that's basically it. So they want us to draw a scatter plot. I'm not too worried about that because if we just do like grams, so 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we go 2, 11, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. And then 6, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 3, 6. It's going to be there. And then 9, 3. Okay. Did I miss the negative on there? I think I did. Oh, there is a negative on the R. Do you see that? So this should have been negative. And the only thing that's going to change is the word positive. Because seeing this, if I were to draw a line through this, it would definitely have a negative correlation or a negative slope. Okay, so once again, that was just, I didn't see the negative when I was looking at the calculator. Okay, we determine the correlation coefficient, so we have that. And then it says describe the correlation between the two quantities, and that's what this does. So if you need additional help, please come to Math Lab. Until then, calculator.